Okay, the last section. Oh my goodness. Algebra will be over with in like a week and a half, and you won't have to stress over it anymore until you get to Algebra 2. So in this section, we talk about solving systems of inequalities this time. They're not equations anymore. When we were doing equations, it was always a line or an equation that we had to solve with a big equal sign in it. Now we're talking about inequalities. No equal signs. This is the less than, greater than stuff. Inequalities. So the easiest way to do these is to always do them by graphing. Always do them by graphing. And since that's the easiest way, and it was the first way I was going to show you anyway, and I'm not bothering showing you the other ways because this is the easiest way. Always do them by graphing. So it's not like with the other ones where you kind of pick and choose which way. This is the easiest, and it's the only way I'm going to bother showing you. So, you know, this is it. You have to first graph each line, which means you have to pay attention because it's an inequality as to whether or not it's dashed or solid. Then you're going to have to shade each line, and you have to decide if you're going to shade up or down. Those are the two big questions with the graphing that you don't normally have. And then the stuff that gets shaded once isn't your answer. It's the stuff that gets shaded twice that's your answer. So let's do a couple so I can show you what I mean. Okay. Example 1. We're going to do x is greater than or equal to 2, and then y is less than or equal to 3. I'm going to do them in different colors so that it'll help you out. But when you're doing them, I'm suggesting you do them in pencil, not in different colors. You'll be able to remember which one's which. I just need you to be able to look at the video and tell which one is which. So I'm going to choose 2 different colors. For the first one, we're going to do the blue so that you can tell that it's blue. And the reason why you got to do pencil is because you got to be able to erase, and it's hard to erase when you do with pencils, something other than pencil. So for the blue, x is greater than or equal to 2. Well, we learned back in chapter 9 that was going to have to be a vertical line, and it was going to have to be at 2. So it's going to look like this. Now the question is it going to be solid or dotted? So coming back over here so that you can see. If it's solid, then it's going to have the symbol less than or equal to or greater than or equal to. It's got that little equal to sign in it. If it's dashed, then it's less than or greater than. That's how you know. So over here, this one has that little equal to sign, so it's going to have to be solid. And then when we're talking about shading stuff, you're going to shade up if it's ever greater than or greater than or equal to, because we always put the y on the left-hand side. You're going to shade down if it's less than or less than and equal to. So those are the 2 rules. This one is different. This is saying all x is greater than or equal to 2. So let me ask you a question. Is 1 greater than or equal to 2? No. But 3 is. So that means it gets shaded on this side. So everything on this side of the line, I'm going to shade, because that's all stuff that's greater than that line. You need to stay away from that color. It's a little too light for you. The bottom one we're going to do in purple. That says y is less than or equal to 3. We learned in chapter 9 that y equals a number. It means it's going to be horizontal. So this is going to be horizontal at 3. That's up here. It's got the equal to, so it's going to end up being a solid line like that. And it says y is less than or equal to. Less than or equal to means I shade down. So I'm going to have to shade below that line. So that means that that's going to be everything here. Anything that ends up being below that line gets shaded. Then you take your eraser. And if it got shaded once, you ignore that. Because it only satisfied one of those if it got shaded once. But if it gets shaded twice, then it must have satisfied both of them. So over here, this stuff that got the blue and the purple, that got shaded twice. So I'm going to keep it. Now, see the lines? You need to keep those in there so I know where they're at. So the lines we're going to keep in, but only leave the stuff that gets shaded twice, because that's really what your answer is. Okay? That one was simple enough, but let's do another one. I'm going to go ahead and draw a new axis for us. Okay. And this one is example 2. And it says y is greater than x and x is less than -2. We use my pink on this one for my y is greater than x. That looks almost like it's a slope-intercept form. I just need a +0 there. So we know it's going to have to go through the origin because that's where it would start. My slope over here is 1/1, so y greater than x is going to have to be like this. Up 1 and over 1, up 1 and over 1, up 1 and over 1. And you can go in the other direction. Now the question is, I got my dots in there. The question is, does it need to be dashed or solid? And since there is no equal to sign here, that's how we know that it gets dashed. So instead of me just leaving the dots there, which is okay, I'm going to go through and dash a line. So technically our line doesn't get shaded, but everything right up to the line does get shaded. Now the question is, now do we shade above or below the line? So that says greater than, so that says up. So I need to go up from the line. Now when you talk about up from the line, sometimes that gets difficult for people to understand. But if you always start at your y-intercept, you can tell immediately that up must be up on this y-axis. So all the stuff up on this y-axis is what gets shaded. Then you expand it out to cover all the way to the line. So it's going to be all of that, all of up here, and all of down here, all the way up to that line. Blue for the other one. Going to end up turning purple in a minute. We want to graph x is less than -2. So my -2 is over here. We know it's supposed to be a vertical because it's an x. And the question is, when it's an x and it's vertical, is it dashed or is it dotted? I mean, is it dashed or solid? So it's still less than. Less than means that it's dashed. So this time I do a dashed vertical line. And then they want me to shade everything that's less than -2. So less than this line means the stuff on this side. So I come up here and I shade all of this stuff. And then you go back with an eraser and you erase the things that only got shaded one time. Even this little part only got shaded one time. And then come down here and erase this because it only got shaded one time. And try to leave your lines in. And that means that this section is the answer to that. It's not hard, and it's fun to color. So this should be a piece of cake, right? I hope you wrote these down because I'm getting ready to erase them. In just 1 second. Okay. 3 more examples. Sometimes they are not in y equals mx plus b form. I mean, obviously, but even this one isn't. And when that's the case, you just need to put it in y equals mx plus b form. So for this one, if I want it to be in y equals mx plus b form, I just need to move where the x is and where the 2 is. So we know that that's really -1 over 1x plus 2. And when I go to graph that, I have to start at my 2, and I put a dot there, and then I go down 1 into the right one. And down into the right, and down into the right, down into the right. And putting these dots isn't going to hurt anything. That's why I go ahead and dot everything. Because even if I have to go back and put a solid line in, I have the dots to go by. And if I don't, it's easier to dash with dots being there than having drawn the line and then try to go back and erase the dashes. So now I've got my dots in. Do I need a solid line or a dashed line? No equal to signs, that means it's going to be a dashed line. So I dash me a line in, put my little arrows, because you can't forget those. Then for the, oh, do I shade up or do I shade down? It says y is less than, so that means I shade down. So all the stuff below on my y-axis tells me that it's going to be all the stuff below this line. For the other one, it says x is greater than 4. 1, 2, 3, 4. So that's this. Greater than means it's a dashed line. And if it's stuff that's greater than 4, that means it's going to be greater than this line. So that's all this stuff up here. Which makes our answer the stuff that gets shaded twice down here in this little corner. So that's the answer in there. Now you don't want to draw a line around that or anything to show that that's the answer, because these are supposed to be dashed lines anyway. So just leaving that as the shaded part is enough to say that's the answer for this system of inequalities. Problem number 4 is slightly more difficult, because in problem number 4, well, you don't have to change the top one, so I could go ahead and graph it. Y is less than 5x minus 1, so that goes through here. And then up 5 and over 1. 1, 2, 3, 4, 5, and over 1. 1, 2, 3, 4, 5, and over 1. Somewhere up there. And then it's no equal to sign, so it's going to be dashed. Okay, that's not very straight. Do I shade above or below? See, lots of people want to, instead of doing above or below, do left or right. That gets really difficult, because left or right isn't always the same as above and below. And what they're really talking about is above or below. So for this one, I want to shade everything that is below this line. Some people think below could be over here because it's below the x-axis, but that's not the case. Below the line, which is why you always go from the y-axis below where it touches. So you can tell which side of this line it's going to be on. And if it's down here, there's everything up here and over here. And you just kind of follow that line on up. So all this stuff in here gets shaded all the way up to the line, but not on the line. So all that stuff gets shaded. For the other one, it's not quite in slope-intercept form yet. Which will make it -3/1 technically. So I've got to go up to 7. 1, 2, 3, 4, 5, 6, 7 things. Like that. Down 3 into the right 1. That happens to be that spot right there. And then down 3 more into the right 1. Down 3 more into the right 1. Dashed. Then it says y greater than. So I want to shade everything above the line. So above the line here on the y-axis is up here, which means it gets all of this, plus this is still above that line. So all this stuff in here, not going beyond the line, just up to the line. And all this stuff over here. So then you have to go back and erase the stuff that only got shaded one time. Well, this only gets shaded one time. I told you to try to leave the lines in there so that I could tell where they were. And then this one only got shaded one time. I mean, it was good shaded, but it was only shaded once. So that's what our answer looks like. I'm going to change up number 5 just a smidge. Make that one an equal to sign. So while I am erasing these to draw my graph for that, you go ahead and try to work on number 5. Remember I said you have to put it in slope-intercept form first before you can graph anything, obviously. You got 2 of those to work with. Let's see what you can do. We'll do the top one in pink. So it started out as 4x minus y is less than or equal to 4. Got to move my x, so I'll subtract 4x from both sides. Get negative y is less than or equal to negative 4x plus 4. Then I have to divide everything by negative 1. Don't forget with inequalities, when you divide by a negative, that means you have to flip the sign over. So now it becomes a greater than or equal to sign. It's a positive 4 over 1x minus 4. So when I go to graph this, I have to start down here. It's going to be a solid line this time, going up 4 and over 1. Pretend it's straight. Then I shade everything that is greater than or equal to, so that's all this stuff up here. Remember, you don't want a tight shade on it, because if you get it too tight of a shade on it, you won't be able to tell where your other lines are. You want to make sure you can see those for graphing the other side of it. The other one, I'm going to do in purple. So that started out as 3x minus y is greater than 6. Subtract 3x from both sides. Negative y is greater than negative 3x plus 6. Divide everything by negative 1. And don't forget, that's going to cause your sign to flip. You get a positive 3 over 1x minus 6. So that one starts down here. And I have to go up 3 and over 1. Up 3 and over 1. Up 3 and over 1. 3 and over 1. Ooh, it looks like it's almost parallel. Up 3 and over 1. Up 3 and over 1. Better go down 3. Back 1. Better redraw this one better. So you can see where they cross down here. That's hard to see. Okay. This is a dashed line, not a solid line. Don't make it happen too soon. All right, and they want everything that is less than. So everything below this point gets shaded. It'll be easier to see on yours than it is on mine because you have a bigger piece of graph paper. You can make straighter lines with your piece of graph paper. I mean, that thing looks really crooked. Anyway, it happens way down here at the bottom where they cross over. So all the stuff that gets shaded once, we can erase. Trying to leave my lines and axes in there some. And all the stuff that gets shaded twice, we leave because that's our answer. Now, you have the question, I know you do because you're smart that way. Is there ever a time when it's not going to cross over? Absolutely. There are times when it does not cross over because they might end up being parallel. And then there are times where it looks like it's never going to cross over. But that's because your graph isn't quite big enough. And that's what happens with those. But this one really does cross down there. You know how I know it's not parallel? Slopes aren't the same, so it can't be parallel. So just make sure your line extends enough. If you find out that it doesn't, you need a bigger piece of graph paper, don't sweat it. Go ahead, erase all that stuff you've got, turn your paper over something, and next time make 2 spaces for every dash instead of 1. But the stuff that got shaded twice is really down there. It's down in there. So that is the last example. The last thing you have to worry about. The last thing before your test. Your mom has the review for you. I'm going to go ahead and tell you what the review is so that you'll know for the next day. Because I typed it, I think, in her email. I think I typed up what the review was, but I'm going to go ahead and tell you too. So if you look on the Chapter 11 Summary and Review, your review is the odd problems, which is numbers 1, 3, 5. Oh, I'm on page 488 if you're curious. Numbers 1, 3, 5, and 9, and 19. 1, 3, 5, 9, 11, and 19. No word problems. Yay! We'll worry about that stuff when we get into Algebra 2. That is not your classwork homework. That's the review for tomorrow, and that's all the review that you get. You have to figure out how to make a better review, because that's all I'm telling you that you need for review. So if that means you go back into your classwork and homework and look over that stuff some more, that's what you have to do. Or if that means that you go back and you look at your quiz some, that's what you have to do. Or if that means that you, I don't know, look at the chapter test in the book, you could do that. All those things are available to you. You've got to use what's available to you to make the best review you can. Classwork and homework for this section. I know you thought you were getting away from it, didn't you? We got some. All right, we got a lot. I figured you'd like it. It's graphing. You like graphing, right? On page 486, classwork. 1, 5, 9, 13, 17, 21. Homework. 3, 7, 11, 15, 19, 23. Now, I might have told your mom slightly different numbers that I'm getting ready to write down for the review. And if I did, go with whatever I told her, because that was right when I made out the test. Page 488. 1, 3, 5, 9, 11, 19. I will say this, on your test, I'll be able to see how you do it. So if it says specifically that you need to do it by graphing, and I provide something there for you to do the graphing on, I need to see it by graphing. If it says that you need to do it by substitution, and I provide space for you to show it, I need to see it by substitution. If it says that you do it by elimination, then I need to see it by elimination. Usually I ask for one of each, and then the rest of them I'll let you figure out whatever you want to do. So yeah, it's been great. I hope you liked the videos, and next year we'll do geometry. Okay, bye.